prevent some of these issues from arising again. So with that, I will forward to the next slide. Hopefully that works. So that worked okay. All right. So to talk a little bit about technical art history, it's an ever-growing field, and it's a place where people from many different disciplines are joining forces. So you have, for the most part, art conservators, art historians who are particularly interested in the materiality of art, scientists, cultural heritage scientists, and certainly, of course, artists are becoming more and more involved. It's a really fascinating field, and as I said, it's where a lot of these really great studies looking into color changes in artworks, it's where a lot of these studies are originating, is when you get groups of these people together and they collaborate and they really come out with some very interesting and incredibly detailed research. So so we have come a long way since the 19th century. That's really the beginning of the so-called golden age of art, of technical art history. So these on the screen are just three of the very important texts that have been authored or translated by the fathers of this movement. But it wasn't really until the 30s and 40s that these documents really became more widely available to the masses. Scholars finally had easily accessible texts, which then provided a window into the technology of art used by artists of the past, specifically information on pigments and dyestuffs as well. So the body of literature has grown massively from these few texts to a veritable library, much of which has been generated by, as I said earlier, collaborations between conservators, scientists, and others. So I've just put a few on the screen here, and there's many more. One just came out, actually, by Archetype, the publisher in London, which I hope you all are aware of. They publish a large number of technical art history texts, and they just came out with one on dyestuffs, which is authored by Joe Kirby, who's a scientist in the National Gallery London. I didn't have time to put that on the screen, but it came out literally a couple days ago. But I should specifically point out the Artist Pigments series, which is a fantastic resource for pigments, and the Technical Bulletin series put out by the National Gallery London. Those are all free. You can download them at the National Gallery's website. And the Pigment Compendium is very, very exhaustive and thorough. And the other two books on the screen are fantastic as well. But with the recent advancements in technology, specifically analytical techniques and instrumentation, we've really started to question our interpretation of some of these early texts that do talk about pigments and preparation of colorants and dyes. This was made very clear at a 2012 meeting in Germany, which was organized to review the current scholarship about the important but highly problematic manuscript that is associated with the scholar Theophilus, which I have on the screen here. Some of you might know this book. Over the past 2 centuries, there has been an ever-increasing volume of publications based wholly or in part on this text. So the participants left the meeting with the consensus that while parts of Theophilus provide excellent technical descriptions, notably for metalwork and pigments as well, other sections are somewhat inadequate or misleading, particularly those devoted to painting. The current thought is that the main body of the text was written not for artists or craftsmen, but for their overseers or even their patrons. This really leads me to the next topic, which is the lives of these manuscripts are very complicated. Ones that we think we know. They almost are you can equate them to almost like cookbooks being handed down from one generation to the next, where somebody will make an annotation in the margin or cross something out if that they don't like or they don't understand. That is very, very common problem with deciphering and interpreting some of these texts. So we have become a little bit more aware of this now in the technical art history field. And you have instances where many people are now starting to go back and retranslate and reinterpret these texts. So what kinds of issues can come up? Well, just translating from one language to the next obviously has its own difficulties. So I have a few examples on the screen. On the upper left, the word azure can be used to describe azurite or lapis, but you can see where that might be misleading in some cases if someone is not aware that the term azure does not necessarily mean azurite. And then on the upper right, I have a recipe. It's one of my favorite because it actually makes no sense, and it's a farcical recipe. But you come across recipes that don't actually, if you were to try to mix these various ingredients together, nothing would happen, or it's impossible. I challenge anyone here to find basilisk powder. And then the bottom is a quote that is basically the crux of my dissertation, which is the very difficult job we have in gathering information about preparation of binding media. So the word tempera is just a generic word that can be used to describe mixing of various binders, not just egg tempera, but oil as well. So with that, I did want to touch upon Cennini because hopefully most of us here have heard about Cennino Cennini. If you haven't, I highly recommend picking this book up if you are a fan of researching historic painting techniques. And germane to this talk, there's a lot of information on historic pigments and dyes. However, we now know a bit more thanks to my colleague Laura Bruck. She just put out a new, I shouldn't say just, 2015, a couple years ago, but in our world, that's fairly recent. I definitely encourage people to pick this more recent copy up. She identified more than 400 errors in the Thompson translation, which is the book that most of us have in our libraries. And a lot of, she went back and she accessed all the different extant copies of Cennini's text, which are split up in various locations, and looked at it with fresh eyes based on what we know today, thanks to analysis of artworks and a deeper understanding of materials. And so while Cennini is definitely useful for those of us that are interested in Italian painting techniques, its cousin, I would say, is this book here on the screen by Mark Clark. This would be its sort of Van Eyckian sister. So this book is the Cennino Cennini, if you will, of the North. It's the Liber Diffusarum Arceum was retranslated, I should say, by Mark Clark. It has some great information in there about what painters from the 13th to the 15th centuries were using. And Mark Clark is, I should say, one of the leaders of this new movement, looking at these texts with new eyes. And he, I have a quote on the screen here. They've identified around 450 medieval and Renaissance treatises that haven't even been touched upon yet. So we have a long way to go in terms of we're always finding more and more information out. It takes a long time to translate, not only to access these codexes and treatises, but to translate them. It's laborious and takes a long time, and we're really just scratching the surface, which is kind of exciting. So hopefully as time goes on, we'll see more information will become accessible to us. And with that, I'm going to segue now into the second phase of my talk, I guess. So to touch upon a little bit about the various types of analytical techniques that we use, what do scientists and conservators use on a daily basis to identify and characterize pigments and dyestuffs? For pigments, polarized light microscopy is very popular. It's not that expensive if you have a microscope in your lab, which often many of us do in conservation. And all of the graduate programs go through a very thorough couple of weeks with the students and train them all on how to analyze pigments using this technique. But I would say a step up from so polarized light microscopy, one would call that, I'll just go back, a destructive technique. And I don't really like to use that term, but that's what our field tends to use, is destructive or invasive techniques versus non-destructive. Why is polarized light microscopy called destructive? Well, we do have to take a very, very tiny sample on a microscopic level, small scraping of the paint near an edge or near an existing loss. Then we'll collect that on a slide and put it under the microscope. So that involves taking sample. So you are removing material from an artwork, albeit very, very, very little. But then conversely, you have X-ray fluorescence, which is wonderful because we don't have to take a sample. And it looks like, I have a picture on the bottom right of two of my colleagues using the technique. The gun looks like a Star Trek ray gun, if you will, but it's actually not harming the painting at all. What's happening here is X-rays are being emitted from the nose of the instrument, and then it's temporarily exciting electrons in the pigments, and they, as they settle back down into relaxed state, they emit specific amounts of energy, and then we get a spectrum, and that's what you see on the screen here. So we can tell when there's copper or when there's chromium or iron, and we know what pigments those elements belong to. Now, it really is truly just scratching the surface, but not in the physical sense, because now I can see iron, but what iron can be in a number of pigments. So it doesn't always answer everything, but it sort of gives us it's a first step. It's a very good first step. And like I said, we don't necessarily have to take a sample. Now, the particular spectrum I'm showing you is a good example of how complicated it can be when you do use XRF. So this was, on the upper left is a detail of a painting that I worked on. This is before any cleaning took place. It's a detail. It's the back of a woman who's, she's crouching down. And the painting was purportedly done in the 17th century. But when we did XRF, we were getting hits for elements like barium, chromium, and zinc. All of these, those three elements do not show up in pigments until the 19th century. And so I knew that we, in some capacity, were dealing with paints or pigments that were not available during the 17th century. So then we decided that we did need to go ahead and take more, we need to take samples in order to get more information about the colorants used in this painting. And that's what we did. So I showed you polarized light microscopy. That is literally just scrapings or tiny dispersed samples of pigments spread out onto a slide. But we can also collect information from paintings with the complete stratigraphy intact. And those are called paint cross-sections. And we did collect one from the back of the woman here in the flesh area, the same place that we analyzed using XRF. And if you look on the bottom left of the screen, I have a red arrow pointing to the sample. That's how small we're talking. Actually, that's a fairly big sample, to be perfectly honest. Our cross sections can get even smaller than that. So we're really talking about along the size of the period at the end of the sentence. And on the right-hand side of the screen is that cross section on its side blown up at about 100 times magnification, and you can see the layers and the ground. So from the bottom up, this painting is on a red ground, so iron oxide pigments, and then after that there's successive layers of light colored paint, which you would expect because of the flesh tone that we see in visible light, just looking at the painting as is. However, I was just looking at the cross section. I can tell what's going on because I have more experience with looking at these things. But if you wanted to know more about, well, I want to know where these anachronistic pigments are coming from. You know, with XRF, we saw that zinc was present, and zinc white was not available to artists until around 1834. So just by looking, simply looking at a picture of a cross section, that doesn't always answer the question. So we then can turn to something even more involved. So scanning electron microscopy is coupled with EDS, so energy dispersive spectroscopy. I know all of you have seen pictures of SEM images online. So if you come across pictures of the bugs of eyes blown up at a amazing level of magnification, those are often taken with SEM microscopes. We use them, however, to get information about the atomic number of the, or I should say the density of the pigment particles, but also where these elements actually map to within the cross section. So you get a really nice idea of this on the bottom left. So that bright pink layer is mapping only for zinc. So I was able then to figure out that the zinc white in this particular instance was overpaint, applied much later, probably in the early 20th century by a restorer. We don't know why it was so heavily overpainted, but you can see it's even on the left part of the cross section, it's dripping down into a crack. So if you find paint in your cross-sectional sample that you've taken, if upper paint layers are dripping into cracks, you know it's been applied at a much later date. But then beneath that, we have really well preserved, original, intact paint layers, and we can tell that from the SEM image and the pigments that are mapping to these areas. So it's lead white used with bits of vermilion and Naples yellow mixed together to give it that sort of peach colored flesh tone for the woman. And then of course all kinds of iron oxides and aluminosilicates in the bottom red ground layer. So that's really just that's just a short summary of some of the techniques that we use in conservation that are, I should say, commonly used. There are far more refined techniques. It's actually a lot trickier to identify and characterize dye stuffs. You tend to require far more sophisticated analytical techniques, so chromatography, high performance liquid chromatography to be exact, but we often have a far easier time analyzing and characterizing inorganic pigments, so things from crushed up stones and minerals, if you will. And I just wanted to throw in an example though of I guess future directions in analysis. So I did talk to you already about XRF, but that gun that you saw, the XRF gun, can only map one spot at a time. But now, thanks to scientists working and collaborating all over the world, but mostly in Belgium and the Netherlands, were able to pioneer this fantastic method of XRF mapping. It takes a long time, but you can actually hook up one of these XRF machines to a scanner and put it in front of a painting, leave for several hours while it scans the surface line by line, and then when you come back, you get these amazing elemental maps. So you can see exactly where copper-based pigments are across the entire surface of the painting, and where lead is, and where mercury is. So, and mercury is found in vermilion. So I have an example here from a paper that was published recently, and it shows you all the different elemental maps, which you can then deduce information from the distribution and use of pigments in the painting. But it's been very exciting technique that has taken off, and they are using it in, I think a lot of the major museums have an XRF scanner now, a system in place, and hopefully some of the smaller museums will be able to afford this technique soon. So I did mention, so I was talking about inorganic pigments versus organic pigments, and I should back up a little bit for just in case people aren't really sure what that means. So I just finished talking a little bit about some of the techniques that we use in the field of conservation and cultural heritage science to analyze dyes and colorants. So now I'm going to go through some examples of color changes, and specifically fading and discoloration that we find during our daily work as conservators. So inorganic versus organic pigments. Inorganic, like I said before, come generally from crushed up stones, minerals. Some can even be synthesized, like verdigris. You see a picture of that in the bottom right. These are most of these pigments that I'm going to talk about initially have been used since antiquity, but I am going to throw in a couple of examples of inorganic pigments that were used, began to be used in the 19th century. So this is a painting that I became quite familiar with when I was working as a contractor at the National Gallery of Art in DC. I had the amazing opportunity to sample this painting and take a closer look at it, not only analytically, but also I got to know the state of degradation this paint was in very intimately when I was looking at it under the microscope. What you're seeing here is this painting is attributed to Antonello da Messina, so it is a 15th century Italian painting. On the upper right is a detail of the Christ Child's vermilion, red vermilion cloak, and this is a dramatic example of the darkening of vermilion that can occur. No one is really sure why this particular painting experienced such a dramatic transformation, but this is a cross section that I took, and you see that darkened crust is very, very thin at the surface, but depending on the painting, that dark crust might be thicker in some instances, but for this particular painting, it is very thin. We have done a bit more research in our field about the causes behind some of this, and it seems that for the most part, it's chlorine that seems to be the culprit. There are other chemical pathways and reactions that can contribute to vermilion turning into another crystalline structure, which is metacinnabar. That is, you might find that in the literature, but it's really, people are finding direct links to the presence of chlorine causing this reaction. And it is really thought that, first of all, chlorine can come from many, many places, particularly the atmosphere. So if you have pollutants in the air, or if your painting happens to reside by the ocean, and there's going to be a lot of chlorine, just ambient chlorine in the air, that could have an adverse effect if it finds its way and settles onto the surface of an artwork. And this particular painting, we don't have a great, we don't have exact knowledge about its provenance, but chlorine could be the culprit in this case. And to move from there to copper-based pigments. Excuse me. Just hold on one second. I'm going to get some water. So we have on the screen two copper-based pigments, azurite and malachite, and they both can suffer from similar issues. So azurite, probably the best image is on the bottom right. Malachite, the finer you grind this pigment, the more likely it will it will lose its color. So you can see that the coarsely ground malachite is very, very deep in color. And then the azurite on the lower left is quite, the more finely ground it is, it will look, sorry, I'm having a cough attack. It will look more gray instead of blue. So this is a problem when you want to paint with these pigments. If you want to preserve their color, they need to sort of, you need to paint with them when they are very, very, very coarse. And if you've ever tried, it is exasperating because it's a bit like painting with sand. And the problem later on is that these pigments can darken considerably. And it does have to do with the fact that they are very large, they're very granular, and things can get trapped down into the interstices of the pigment particles, as you see here. This is a cross-section taken from this Lorenzo Monaco, and the middle layer, you can see the darkened azurite in the central layer, and then up top, you have these beautifully preserved ultramarine pigment particles that don't suffer from this problem. But the oil medium in the center is quite dark and quite discolored, and it tends to it's a combination of getting trapped within the matrix, the paint matrix, but also the copper in the azurite can react with the acidity of the oil and turn quite dark and quite yellow. All right. Smalt. Smalt is a beautiful blue when you begin painting with it. As you can see in the center of the three swatches that have been painted out. The problem with smalt is that it is actually a potassium glass that's ground down that contains cobalt. And when that pigment is suspended in oil, the oil can actually leach out the cobalt from the matrix, from the glass matrix, and the cobalt is responsible for the blue color of this pigment. And so what you end up with is this brown, muddy, murky mess, and you can see that really well on the left side of the screen. So these are two paintings done by Hans Holbein, and the right one, the blue background, has been very, very well preserved. And on the left, we have an example of the small discoloration that is above and beyond what one would normally see, but it can get really, it can be very dramatic. This is, the small discoloration is most commonly encountered in Dutch 17th century paintings, particularly with Rembrandt's paintings, but this is the earliest case, I believe, that we've come across examples of the discoloration of smalt. It is not, there's no explanation, because these are two separate paintings. There's really no explanation as to why the one on the right has fared very well and the one on the left has not. I'm not sure if medium analysis has been done, but it would be interesting to find out if there would be a difference in medium in the background on the right versus the one on the left. We know the one on the left is oil, but we don't know what the one on the right is painted in. It could be a mixture. I have no idea, but it is curious, and it's a question that remains unanswered as to why one painting has suffered so much and the other has not. Holbein, for those of you that don't know, did generate many copies of the same painting for his various patrons during his career. So malachite can also suffer from a similar issue. You can see from this painting, this is a painting I treated when I was at the National Gallery. I took a sample, a very small cross-section from the stem of one of these roses that had completely turned black. And you can see from the cross-section, in magnified, there's actually brilliant green spherical malachite particles still intact that we completely we can't see anymore. And if you look at the infrared reflectography or reflectogram on the right, I'm not going to get into IR here, but basically what the infrared is showing us is there's actually shading in detail, beautiful shading in detail in these leaves that is now lost because of the darkening of the malachite over time. So they were highlighted and shaded, and hopefully you can see that on the right. But as time has gone on, it's become so, the green particles have become so dark and discolored, they almost look black. And again, it's a very similar chemical reaction that's what I described earlier with the azurite. Verdigris is a horrible culprit for discoloration. More so, I think, than azurite and malachite. It is a copper, it's for the most part, it's because of its chemical makeup. It's a copper acetate that can be synthesized. And it's honestly one of the reasons why a lot of these paintings, old master paintings, tend to look like they're always painted in the fall. And it does tend to convert to a red or brown version, cuprite, which is what we end up seeing 500 years later. It is very reactive. It reacts quite adversely to the oil medium. Again, the acidity of the oil doesn't help here. And you can see that just after 3 months if you paint this out in traditional oil binders. This is taken from the Artist Pigment series, I believe, this particular example. So that really brings me back to what I was starting to discuss at the very beginning of this talk, which is the importance of reevaluating old texts. There's sort of been this myth around copper resonate, which involves verdigris. And AP Laurie, his text, he came up with so this sort of legacy of copper resonate really began with his research. So he claimed to have seen these glazes on illuminated manuscripts. And he felt that these colors were most likely prepared by dissolving particles of verdigris in heated solutions of resin, like mastic or sandarak. And there's an example of that, what that looks like under high magnification on the lower right of the screen. Analysis has since shown that these colored glazes found on medieval and Renaissance paintings are typically bound in oil, though, and not resin, like A.P. Laurie thought. But there's generally an absence of discrete pigment particles when we do come across these glazes. So were these the question remained, were these particles disappearing because they were being heated, as Laurie thought, or was this simply due to the reactivity of the verdigris pigments themselves? And this is really where the reconstructions, so actually reconstructing old recipes and using historically accurate materials becomes really important, because they can help us answer these questions, especially relating to discoloration and pigment reactivity. So this was a wonderful study done by Marguerite van Eyck-Mahomes in 2009. She published this. So she painted out some verdigris in oil paint and took some images using polarized light microscopy, which I talked about earlier, and waited for many, many months and tracked the same pigment particles over time. And they began to just dissolve on their own because they were so reactive within the oil matrix. So it's not to say that copper resonate, the recipe that Laurie stumbled upon, wasn't used. It's just that we can't really prove that it was ubiquitously used, because we don't find discrete pigment particles, we know that verdigris will sort of dissolve over time no matter what, especially when it's bound in oil. Reconstructions have also been very, I'm just going to digress for a little bit on color changes, although lead white can induce changes, which I'll show in a minute. But reconstructions have also shown us some fascinating things about lead white and it's associated with its production. So The HEART project began in 2002 and ran for many years. It was headed by Dr. Leslie Carlisle in Amsterdam. And they went so far as to actually find and track down the flax plants that were most likely related to the flax plants that generated the linseeds that made the oil that was used by Rembrandt in his workshop. So using genetically related flax plants, they mold up some historically prepared Dutch lead white and actually did a number of studies for, like I said, over a period of years. For those of you that don't know how lead white is historically made, because we just tend to, most often, we tend to buy the commercially prepared lead white pigment that is synthesized. You basically suspend lead metal, sheets of lead, over vinegar, and you put it in a little crucible and you cover it with manure. So the lead or the vinegar will react with the lead metal, will turn it to lead acetate, and then the carbon dioxide from the manure or rotting grape skins, that was another trick, the carbon dioxide will then act on the lead acetate and turn it to lead carbonate. It's a really smelly endeavor, and to my knowledge, only a handful of people are manufacturing this stuff, but you can actually get it today. And why I'm bringing it up is because it moves very differently from commercially synthesized and prepared lead white. And you can tell that from these SEM images that I am showing on the bottom of the screen. You have these very fluffy agglomerates of lead white particles. They can range in size as well because it is made in a natural way, as opposed to the particles that are on the right-hand side. They're more like sheets almost and very angular. So that actually will affect your paint handling. And artists that I've talked to that are really familiar with both kinds of lead white will definitely tell you that there is a massive difference in the paint handling itself when you're comparing these two types of pigments. So getting back to color changes or changes in art in general, lead white, even though it's withstood the test of time and it is a great, wonderful, resilient pigment, it can also become more transparent over time. And the reason why is that it can react with, again, the oil matrix or anything that has fatty acids, so to some extent tempera as well. It can form something called metal soaps, and it's basically the free fatty acids in the oil will start to migrate towards these centers where there are lead cations, and you end up with these sort of, you could see this on the bottom right, these sort of clear lead soaps, and their refractive index is much lower than the surrounding paint matrix. So that is one reason why over time old master paintings can become more transparent. And a really good example is on the left, where you have some of these Dutch landscape painters who are painting in a very, very thin layers of containing lead white. But as they age, those lead soaps will start to form, and that's why we can see the wood grain so easily. They weren't originally like that. So it does have to do with an increased transparency of the paint over time due to the formation of these lead soaps. They can also form these pustules, which I have an example of in the bottom right, which are very unsightly. And while we do actually need lead soaps to form because they are responsible for the strength and integrity of the film, having too much of them is a bad thing, and they can migrate up to the surface and form these pustules and then eventually pop off. And there's nothing really to be done about it. It's just a phenomenon that we're aware of now, and we document when we see it. And it's something that is continuing to garner more interest and research in the conservation science community in particular. Lead chromate, on the other hand, can be very reactive, and a good example of this can be found in some of Van Gogh's paintings. I have a image of a cross section on the lower left, and you can see that dark crust that's formed on the upper layers of the lead chromate paint layer. This is mostly to do with interacting, again, with pollutants in the atmosphere. Lead chromates do not play nicely if they're exposed to poor atmospheric condition pollutants. And you end up with a very, very drab-looking paint layer, which originally was much brighter and much more yellow. Zinc white was, like, as I said, sort of entered onto the market in around 1834 and was embraced wholeheartedly by the pre-Raphaelite painters. This is a wonderful painting by Holman Hunt. They tended to use it often in their grounds, but zinc white, we now know, can create very, very brittle paint films. And while I didn't know whether I should put this into the talk or not, because it's not really a color change, but it is a huge change. And I did want to raise some awareness for those of you that are artists in the community about the problems associated with zinc white. Zinc white, when you mix it with oil, can create a very brittle paint film over time, and it can lead to cracking and sometimes flaking. This is a very good example. I was at a conference in Amsterdam a few years ago, and this was a poster on one of Mondrian's works, and you can see on the left is an image of the painting. In the middle, we see magnified images of the paint film itself actually cracking and flaking. And on the right-hand side is an image of the same painting with raking light. So it's directional light striking across the surface of the painting, so we can see how bad those deformations are where Mondrian painted with zinc white. There is, again, not much to be done about it. It is a serious change that can occur in some paintings, but I should say there's also some paintings that we find zinc white on and they're fine. So we have no real answer for why some paintings are faring well and why some aren't. The rule of thumb, I would just say, would be to use it sparingly when you do use it. And if you are going to use it, record it on the back of your painting so we know that you did, although we probably years later would be able to find out very easily if you have. But this is, I consider this to be a major change. It might not be a color change, but it is a major change that some modern contemporary paintings are experiencing. So to just sort of wrap things up, because I know we're getting towards the end, I wanted to give a few examples of color changes as related to organic pigments. So organic pigments, as opposed to inorganic pigments, are obtained from crushed up bugs or berries or even fungi, lichens, and they tend to really fill the gaps in the color spectrum for the traditional painter working in the medieval and Renaissance times, because you really can't get that red color that you associate with a ruby in the 15th century. If you crush up a ruby, you get white powder. You don't get colored powder. So this wonderful discovery of cochineal and kermes also came along, where you were able to extract brilliant red colors from these bugs. And we're even able to sometimes, it's rare, but we can, this happens more often with textiles than with paintings, but we can actually, on rare occasions, date paintings based on what type of cochineal dye was used in the paint. So you have Old World cochineal and Polish cochineal, and then New World cochineal, which obviously was discovered in the Americas, Central and South America, after the discovery of the New World. If you find New World cochineal in a painting that wants to be from the 1400s, or I should say that wants to be from the early 1400s, you know that there's a problem there, and you might have to have a talk with your curator or the client who owns the painting, because New World cochineal will not show up in paintings until after 1492. But it is just an interesting thing to keep in mind. The problem with these materials is that they're exceptionally fugitive, and they will fade within our lifetimes easily. And it just has to do with the chemical composition of them. The fact that they are organic, they're very susceptible to damage from UV light. And you can see that in this cross section here. Same with indigo. It is also prone to fading. You can see an example of this, this painting where it was protected along the frame, along the outer edge. You could see the original color of the indigo retained, but then moving towards the center of the painting, you can see it where it's become much more faded. Yellow lakes, also, again, very from stildegrain or buckthorn berries. These were typically mixed with blue pigments, so something like Prussian blue or even azurite or smalt to obtain green. And when the yellow fades, you're left with the blue pigment. And that is why sometimes you come across these Dutch still life paintings with blue leaves, because that's an instance where the yellow lake has faded and the blue is left unchanged. And finally, ending with some examples of fugitive modern organic pigments. This is something that I highly encourage everybody to educate themselves on. There are rating systems in place for modern organic colorants that you can check. There's light fastness ratings, and these are two paintings that are really good poster children for why you should care about that. We have the same yellow lake problem going on with the Hopper painting on the left. Those are not blue spruce trees. They were once green, but this is instead of a traditional yellow lake dye fading, this is a modern yellow dye that is faded. And on the right, some of you are probably well aware of Van Gogh's struggle with the Eosin red dye that he would use. So these roses were originally far more pink, and they have since faded. And he actually witnessed that happening in his lifetime and wrote about it to his brother. So how has our field dealt with some of these color changes? Digital reconstructions are a really good way to go, and the Van Gogh Museum has actually done some wonderful examples of this. With probably the most famous example is the bedroom, this painting. You can see how faded that red lake is on the bottom cross section, but they were actually able to look at other paintings by Van Gogh and other sections of this painting where the dye had been preserved, use that, and then extrapolate the digital reconstruction that you see on the right to give the audience and the viewers an idea of how it may have originally looked. There's a lot of math and computational science that goes into churning these out. It's not just somebody playing around in Photoshop. So it's a whole new area of research that is really fascinating and picking up speed. Probably the most extreme example of modern dyes fading is this example by Rothko. The Harvard murals were made in around the 60s, a series of them, and they were bright, brilliant pink and red, and just in a matter of 30 years or so, less than 30 years, they faded. So you see the 1963 photo, right, very soon after the painting was done, and the 1988 photo, and that is from fading. So that is what we're seeing is fading of a lithol red dye, very, very fugitive. They were then basically declared to be quote unquote dead paintings and kept in storage for ages up until a few years ago, where when the Harvard team, imaging scientists and conservators got together and they teamed up and they came up with this ingenious solution of actually projecting light on the faded paintings, and then the end result giving you an approximation of how they originally looked when they were first created. They had a whole exhibit on it, and they've published extensively on it since then. That is the first time, to my knowledge, that anyone's used a technique like that to sort of, quote unquote, bring a dead painting back to life. So everything that I discussed today, you can find in this wonderful new publication, Color Change in Paintings, appropriately titled. And I just actually finished a book review for it that is going to be out in a couple days. But it is affordable, and I highly encourage you to check it out, because some of the examples that I talked about today are detailed extensively in this publication, which is a series of essays written by scientists and conservators. And also, if you are just more interested in learning about historic painting techniques, tempera and oil, specifically regarding the use of pigments and so on, please feel free to visit our CREST Technical Art History website at UD. It's a shameless plug for our website there. And then, while our CREST Technical Art History website focuses more on traditional and historic materials, as was mentioned at the very beginning, Mitra is our new forum, and you can go on there and ask questions about modern pigments that you're using now. If you have concerns about fading or questions about light fastness or reactivity, you can join. It is free once you make an account, and then you can post your you can post your question, and a number of moderators, which consists of scientists and conservators and artists, color experts, we will all do our best to answer whatever question you have. And on that note, I just want to say thank you to a number of these people, especially the Color Society, for inviting me to do this. This was a real pleasure and a first time for me, and thank you very much. I hope everybody enjoyed it and got something out of it, and I guess we now open the floor to questions.
Hi, Kristin, thanks very much. Yes, we will open for questions, and of course, thank you properly at the end. So we're all a little bit new to this technology, so we'll have to see how the questions go. I think I just wanted to ask one straight away on behalf of modern painters trying to paint and looking at some of this in horror and saying, well, can you give us some basic rules of thumb how to keep painting and not have to worry about the materials too much?
Yeah, I would just say, just keep painting. Just keep painting. It's not, it's very, very easy to become far too stressed over the use of materials. I just want you to be a little stressed. That's all. No, but I'm joking. In essence, you really just need to paint and use what you can afford and what you love to paint with. But if you do come across, if you are worried about potential changes or issues, you can ask about it, and you can ask about it on Mitra, and we'll give you some feedback. If you feel that you absolutely cannot part with a particular color or pigment or material, that's fine. You should just record it on the back of your painting or your artwork in any way you can. So it's up to us then in the future to figure out how to interpret it and how to best care for it. If we know, for example, that you love a pigment that is very fugitive and sensitive to light, then conservators and clients, galleries hopefully, will take note of that and then take the necessary steps to exhibit them properly and to care for them properly. So it's really just a matter of making sure you try your best to record the materials you're using, and to not stress too much, because it's very easy to get wrapped up into the world of materials and get a little bit stressed. It's our job as conservators to really hone in on the extreme cases. So extreme cases of fading and cracking and discoloration, when there's an example of everything that I showed you today, there's examples out there where that hasn't happened. So it's not just because you use vermilion does not necessarily mean it will darken. Absolutely not. It's just it can happen, and we're trying to learn more and more about this specific chemical pathways as to why it does happen and what we can do, therefore, to prevent it in the future.
Well, thanks very much for that. So I think I'll just open it first of all to those that are actually here at the physical meeting, and then after that we'll see whether we can raise some electronic hands. So is there anybody here that has a question for Kristin? Yes. Yeah, but probably just come over here. Thank you.
Hi, Kristin. I just
Hi.
wanted to ask your opinion on alkyd-based mediums and how they might be better or worse than straight linseed oil, for example.
Oh, wow. My opinion is that I don't think there's any issues with them so far. I know that some painters feel that because they're not they're not a natural binder, meaning they're not something like made from eggs or flax seeds or other types of oil mediums, that they might be problematic. But we so far in the conservation community haven't seen any issues with them in terms of becoming brittle over time or what have you. The issues with alkyds is really they suffer from similar things that oil films do, if any. So they will tend to yellow a little bit over time, and if they will become brittle, but only to the same degree that oil will. And actually, they're more flexible than many oil films because that's the nature of alkyds. So I don't really have a problem with them as a conservator. But if you want to know more, I would definitely suggest going on Mitra and just putting in the word alkyd in the search bar. I guarantee you that other people have posted similar questions, and you can read about that on the forum. Also on Mitra's site, I forgot to say, there's a resources section that's really easy to miss. If you click on that, there's all kinds of PDFs with links and everything embedded in them. You can go to the mediums and additives document, and there's a whole section on alkyds, and our take, Mitra's moderators and team, our take on the pros and cons of using alkyds, essentially. So you can definitely find out more information there.
Thanks, Kristin. So I think what I'll do now is just go to the electronic. Sorry, is there any more questions from this end? David? Yeah, I think David might have a question. Just one second.
Actually, not a question, just to thank you for so much, Kristin. It's really, the internet's a great thing, and we have all this information being shared, but a lot of disinformation gets shared as well. So it's fantastic that there's a reliable, authoritative place that we can go to for technical questions. So it's Mitra is a fantastic initiative. So thank you.
Yeah, sure. I should say also, we are really, really thankful to the support that we've received from the paint industry in particular, and the art supply industry. All of the companies out there that you all buy your materials from, they are also very well aware that there's a lot of misinformation being circulated, and they want the right information out there available to artists about their products and about materials, because things can, as we know, on the internet, it can be a bit crazy. So they have been very supportive of our endeavors at Mitra, and they finally feel that it is a good sort of unbiased place where you can get a lot of this information. So not only do we have conservators and scientists and other professionals as well weighing in with their expertise, but we also will phone in people that are from Golden or Natural Pigments or Gamblin, people that know that if there's a specific question that comes in, for example, about Gamsol or something to do with a pigment sold by Kramer or Natural Pigments, we will actually ask them to weigh in as well, because they're the ones making it, and they're the ones who are willing and best able to share information about their materials. So I should say that.
Thanks, Kristin. There was actually one question just from the talk itself. You mentioned the difference between the lead white that's been manufactured now and manufactured through the stack process. So is there, I mean, for a lot of the realist painters, they, you know, which white they pick is an important question, and, you know, people have strong views on lead white and titanium and so on. Is there a reason to believe that the lead white that people are using now will age very differently from the way that the lead white has aged in the paintings you're familiar with?
I don't think so. Not particularly. Not in any way that I've seen. I think that so I talked a little bit about lead stope formation. That could potentially happen with historic Dutch stack process or commercially prepared lead white. So it really doesn't matter in terms of aging properties, to my knowledge. Maybe a study will come out in 10 years proving me otherwise. But no, the main difference is really the particle size that I showed, and that's the main difference, and that's really what causes the difference in paint handling and why some people gravitate towards one or the other.
Right.
Does it with varnishing have an impact on the fading of the paint?
Yeah. So we've got a question here from Sally Ryan. She was just asking about varnishing. You know, generally speaking, when you're talking about varnishing or not varnishing, how should we think about it? And does it make a difference to the longevity of a painting?
It's a really, really great question. And again, I will point you towards Mitra. The resources document on varnishes talks about that. But I will say that, so fatty acids in oils, alkyds, and tempera egg tempera will continue, and wax medium will continue to move and migrate over time. They just will. So kind of an extreme crude example would be a chocolate bar over time that forms that sort of gray hazy crust on it. Those are free fatty acids that are migrating to the surface. Obviously, we don't see that degree most of the time occurring on the surface of paintings, but there are some examples that can be pretty bad. Varnishing will mitigate that, and it will essentially stop the migration of fatty acids. It seals the surface, and it prevents those fatty acids from migrating where they want to go. They want to go towards the surface where there are no fatty acids. So varnishing will definitely help prevent that. But on the other hand, there are artists who don't want their paintings varnished, which is perfectly fine. And again, I say to those artists, just let us know, write that on the back of your painting. Then we'll know we'll be better equipped on how to deal with preserving the surface that you want in the future. So I'll just say that. But yeah, varnishing is known to mitigate it's called efflorescence, the efflorescence of fatty acids.
Thanks for that. So I'll just open up to general questions now. So I think the other participants, if you look at your screen towards the bottom, you should be able to click on participants, and then there should be an option for you to raise your hand. So if you want to raise your hand, now's the time to try to do that. Silence, no raised hands. Okay, well, in that case, I think, Kristin, we should say thank you very much. We understand now why you are already such a valuable resource on the online forums on these issues as well. This has been a really awkward time, and I know quite a bit of present work has gone into it, so I really appreciate that. We all do. And we were sort of debating on the best way to express our thanks, but hopefully some kind of Amazon voucher will be coming your way at some point. But in the meantime, on behalf of the Color Society and the whole audience, I'd like to thank you. Thanks very much.
Thank you.
Thank you.
Thank you. Thank you very much, everyone. Okay. Have a great night. I'm going to sign off. Bye-bye.